good morning. So this is C. Senthil Kumar, Assistant Professor in the Department of Mechanical Engineering. So in this class we are going to discuss something about the basics of heat transfer. So this session covers what is heat transfer and what is the difference between heat and temperature, and what are the modes of heat transfer and the law behind each type of heat transfers. So these are the things we are going to see in the session. So first of all, we should know what is the difference between heat and temperature. So heat is nothing but it is simply we can call it as it is a calculatable property. So heat is the form of energy that moves from one body to another surfaces due to the temperature differences. So whereas in temperature it is a measure of a thermal state of a particular system or particular point. So temperature is the point function. So we can measure the temperature at a particular point only. So it is called as point function. And whereas in a heat transfer it is a path function. We can say that heat transfer is a calculatable property. We can able to calculate the property heat transfer with the help of some mathematical relations. Whereas in temperature we can measure with the help of some instruments. Okay, so this is the main difference between the heat and temperature. So next slide shows the importance of heat transfer. So by studying or by knowing the understanding of the basic principles behind the heat transfer, it is very useful to operate the thermal equipment very safely, and we can able to save the energy for future and human comfortness and food preservations, and we can also reduce the global warming. So few applications of thermal engineering are refrigeration and air conditioning systems, in power generation units, automotive systems, and building designs. So and also the heat transfer, the basic principles of heat transfer plays in our everyday life. So like cooking, heating, cooling, etc. And the next slide shows that the different modes of heat transfer. So we all know that there are three modes of heat transfer. One is conduction, convection, and radiation. So these are the three the various modes of heat transfer or the type of heat transfers. Where conduction is nothing but it will happen generally the heat transfer takes place from higher temperature side to lower temperature side. So in conduction the heat is transferred from one side to another side with the help of a medium or direct contact between the surfaces. So that type of heat transfer is called as conductions. So conduction is the direct flow of heat through a material resulting from the physical contact. Whereas in convection the heat transfer process takes place via fluids, or simply we can say that the heat transfer between the surface and liquid. So I mean that fluid. So this is the convection type of heat transfer. In radiation, the heat transfer takes place via the electromagnetic waves. So these three are the very important or types of heat transfer, the different modes of heat transfer. So we will see one by one. So first conduction. So conduction, there are two types of conduction. One is called steady state heat conduction, another one is called unsteady state heat conduction. So steady state conduction means it is depends on the temperature. Temperature is constant with the time, whereas in unsteady state temperature varies with the time. Okay, so this is the main difference between the steady state heat conduction and unsteady state conduction. So for example, for steady state heat conduction is heat transfer through walls in a house under constant outside and inside temperatures, and heat exchangers and various insulated thermal systems are the few examples for steady state heat conduction. Whereas in unsteady state heat conduction, heating a cold object or cooling a hot object over a time. So this is unsteady state heat conduction. Here the temperature varies with the time. So some quenching process or sudden cooling process, sudden heating process is best example for the unsteady state heat conduction. So in this figure shows that the best understanding of conduction through of heat transfer. So take a rod, iron rod or steel rod, you can apply the heat at one side. So gradually the heat is transferred from one side to another side. After some times we will absorb the heat in our hand. So this is the good example for the conduction type of heat transfer. So uh, so the law behind the for heat conduction is called Fourier law of heat conduction. So this law is invented by the Joseph Fourier. So the definition for this law is the heat transfer rate is directly proportional to the negative temperature gradient and the cross-sectional area through which the heat flows. So this is the definition for the Fourier law of heat conduction. So this is the main law which is behind the conduction type of heat transfer. So mathematically we can say that Q is equal to minus Ka into dT by Tx. So here Qx is nothing but heat transfer per unit area. A is the area of the material and K is the thermal conductivity of the material. It is nothing but thermal conductivity is nothing but the ability of the material to conduct heat. The unit for the thermal conductivity is watts per meter Kelvin. So every material has a unique value of thermal conductivity. Whereas in dT by Tx is called as temperature gradient. And the negative sign indicates that the heat flows from the direction of decreasing temperature. So this is the Fourier law of heat conduction. So next we'll move to the convection type of heat transfer. We already discussed the convection takes place between the solid and fluid medium. So as like conduction, the convection is also two types. One is called free convection. It is also called as natural convection, and the second one is called forced convection. So free convection takes place due to the density differences, and the forced convection will take place by means of some external forces. So in this slide there are two figures. One is for natural convection, another is called forced convection. In natural convection, flow is driven only by the temperature difference. So due to temperature varies, the heat is transferred from solid medium to fluid medium. Whereas in the forced convection, the external force is applied to transfer the heat from one place to another place. So in the right side corner figures indicates the clear understanding of convection type of heat transfers. Okay, when you are going to heat the water at the bottom side, so at bottom of the molecules first absorb the heat and it will move the upward direction due to the density differences. Like that the heat is transferred from bottom to fluids. So the best example for the convection is natural convection is cooling a cup of coffee, opening window for ventilation and drying clothes. Whereas in forced convection, ceiling fans, air conditioners, car radiators, vacuum cleaners, hair dryers. So these are the few examples for the convection type of heat transfers. So as like Fourier law of heat conduction, convection also they are having one law called Newton's law of cooling. So this law states that rate of heat loss of a body is directly proportional to the temperature difference between the surfaces. So it is also called as Newton's law of convection. Okay, so mathematically you can say that Q is equal to HA into TW minus T infinity. Q is nothing but heat transfer rate, and H is the heat transfer coefficient, and A is surface area, TW is the surface temperature, T infinity is the ambient temperature. Here the new term is called heat transfer coefficient. It is nothing but it is a measure of the ability of the material or fluid to transfer heat between a solid surface and fluid surface per unit time and per unit area. So this is the Newton's law of convection. It is the main law which is placed behind the convection type of heat transfers. So next we will move to radiation type of heat transfer. So radiation is nothing but the heat transfer takes place via electromagnetic waves. So simply we can define the radiation. Heat energy is transferred from one place to another through electromagnetic waves without need of any medium. Okay, so the figure shows the various examples for the radiations. So sun radiations, radiations from the fire. So these are the few understanding of radiation type of heat transfer. So here also a law plays a very vital role behind the radiation type of heat transfer is called Stephen Boltzmann's law. So mathematically we can say that Eb is equal to sigma into T power 4. So it may be defined as the amount of radiation emitted by an object is proportional to the fourth power of the absolute temperature. So EB is nothing but heat transfer emitted by the surfaces. Sigma is the Stephen-Boltzmann constant. It is a constant value, and T is the surface temperature. So in real world, the radiation plays in the following applications: spacecraft designs, climate sciences, and engineering, thermal installations like that, etc. Next, we can see that examples of radiation: ultraviolet light from the sun, heat from the stove burner, visible light from the candle. So these are the few examples of the radiations. So that's all from this session. Thank you very much. Thank you.